LTE uses MIMO technology to improve throughput. This means there are multiple transmitters, and the composite EVM measurement must now take into consideration each transmitter in providing a measure of modulation quality. The instruments used for the LTE MIMO composite EVM measurements are two N5182A MXG signal generators, two N9020A MXA signal analyzers, one instance of the 89600 vector signal analyzer software, and the N7624B Signal Studio for LTE software. Here we have a 2x2 MIMO system setup. The MXG signal generators, with LTE configuration from the Signal Studio software on the PC, represent the transmitters under test. The MXA signal analyzers and VSA software are the acquisition hardware and analysis software that performs the LTE MIMO composite EVM measurement. In this case, the VSA software, running on the PC, accepts the data from the two acquisition streams and controls the MXA all via LAN. The VSA software also works with a multi-channel Infinium oscilloscope as the acquisition hardware to make the same measurement. Let's take a look at how simple and fast it is to make this measurement. But first, let's configure a test signal using the Agilent Signal Studio for 3GPP LTE for FDD mode. Here we've configured a downlink MIMO signal with spatial multiplexing and 2 layers. And we've configured the modulation to be 64 QAM at 10 MHz, or 50 resource blocks. Once we have generated and downloaded the signal into our signal generator, we can go to the Agilent 89600 Vector Signal Analyzer and look at the inputs of both MXA signal analyzers. We range the VSA for the proper signal level, which in this case is 0 dBm. You can see the 10 MHz wide LTE signal coming from each input. To begin the modulation analysis, we turn on the demodulator by selecting 3G cellular from the various groups and then specifically selecting LTE. The demodulator comes up in a preset condition for a single transmit antenna signal. Since we have 2 transmit antennas, we need to configure the demodulator through the Demod Properties dialog box. First, we preset to standard for a 10 MHz signal, which is what we have. Then we configure the analyzer for 2 transmit antennas. Next, we configure the signal profile and select Edit User Mapping. Then select the 64 QAM downlink shared channel with spatial multiplexing and change the number of layers from 1 to 2 layers. Now that we are properly configured, we can close the Demod Properties dialog box. Now we see here the composite constellation and spectrum. To view more traces and results at the same time, we change to a grid 2x3 format. This gives us 6 traces on the screen, as you see here. Adding error spectrum, error time, frame summary, and error summary. This error summary shows our key measurement EVM, or composite EVM. In addition, peak EVM, the EVM for the data channels, and the EVM for the reference signals is also provided. Being the most basic measure of modulation quality, composite EVM is an initial step to investigating transmitter quality. From here, you can investigate more detailed MIMO characteristics, such as time alignment or power characteristics between transmitter branches. For more information, contact your local Agilent Technologies representative or visit www.agilent.com/find LTE.